Hello, good morning, and thank you for joining me in my shop here. It's December 12th today, and we're waiting for another big snowfall to come a little later today. Could be half a meter, or maybe not. It's hard to say because it's that lake effect type snow coming from the Lake Huron and Georgian Bay. Okay, what about this radio? Well, smoke came out of it. And I operated it again with the viewer, and I could only locate one thing that was getting warm, and that was this, and it wasn't getting all that hot. And plus, nothing else generated smoke or seemed to be hot. When I was putting the video together, which you may have watched, right towards the end when the event took place, and I got the viewer out, you could see two spots in this radio quite clearly. You could see this resistor and another spot down in this area. When this kind of thing happens after I've done work on a radio, the first thing I assume, and I should assume, is that I messed up. I made some kind of mistake. Usually the mistake I make is I somehow, try as I may, I get these electrolytic capacitors in backwards. I was very, very careful this time to not have that happen, and I'm happy to say that didn't happen. I didn't get them in backwards. But in examining the schematic this morning, I realized, yeah, not backwards, wrong place. So there's three capacitors I installed. Two of them are on the power supply, and one of them is a bypass capacitor for the output tube cathode resistor. This the third capacitor, if you like, doesn't sustain much voltage, maybe 20-30 volts. So you can put a low voltage capacitor in, and I did. It's sitting up here. I used the wires that came from the other capacitor to identify these two as being the two high voltage ones, and this odd colored one would be the odd one, the 20 microfarad 25 volt capacitor. Didn't look any further, and that was my mistake right there. I got these wires interpreted wrong. Consequently, I put the capacitors in the wrong position. Consequently, I put this low voltage 50 volt capacitor into a position where it's going to sustain probably 100 volts or so. And that's the guy who fried up, I'm quite sure. So what I'm going to do, even though now I have a very large capacitor in as a bypass capacitor, for now I'm going to leave it there. Probably doesn't make any difference. It might, but I think it probably won't. And I'm going to replace the small, thought it was a bypass capacitor, with a full size, another one of these. And that should settle the problem down. And I'll just do my best and I'll put it in backwards. And then we'll see what happens. Okay, next capacitor is in. Here's the little guy I took out. Let's take a close look at it. It looks just fine. It's hard to believe it would look fine. Okay, here, just one sec. Might have trouble getting this to focus. To do it manually. Yeah. Let me stop and get that camera working the way we want it. Okay, let's take a better look at it. So what we're curious about is, does it have any evidence of burning up? I'll have to get another one out right beside it. This looks, it's hard to say. Let me get another one out that's not cooked, and we'll take a look. Okay, can we see evidence of cookerage on this? The closer one is the one that was in the radio. The farther one may not be exactly the same size, but it's the same type. I think the ink looks a little different. The gold colored ink. Well, maybe not. Yeah, you'd be hard pressed to look at this one and go, yeah, it's overheated. Now that's a little bit of a worry for me. Maybe I've misdiagnosed the problem. Well, that looks a little different. Let's look at the bottom of this one here. Wow, there's a distinct difference there. The cooked up one, it looks like the shrink is kind of pulled away at the bottom there. These aren't exactly the same size physically either. They're pretty close, aren't they? Like you see how on the one on the left, the shrink cover touches the lead here by my finger. By the way, that's paint on my fingernail. I'm in the middle of painting a room in the house while I'm doing this. Boy, it'd be pretty hard to look at this and say, oh yeah, I can see that it's over here. We're going to put a test on this. Maybe it looks a little rougher. Nothing dramatic, that's for sure. Okay, let's do a test, and we'll find out how this still works. How much you want to bet it tests perfectly good? Come on, how much? What have I got handy here? Okay, I got a Canadian dime. 10 cents says this thing tests perfectly good. Of course, you have to come here to collect your 10 cents, but here we go. What does it say? Capacitor. 19 microfarads. So, that's not terrible. 0.7, 1.2. 19 microfarads. And it's supposed to be 22, I believe. Let me just read what it says right on it here. 22. Well, I don't know. I'm pretty sure that's a thing that smoked. I mean, there's a good reason for it smoking. It would have had 100 volts on a 50 volt part. Okay, I gotta put this guy away. And I'm gonna toss this one out, because goodness knows what condition it's in. Cut the leads off anyway. It's a goner. Okay, well, I think I'm gonna retain the dime. Here we go. Can you tell he's bigger? The cats keep getting bigger. Get out of the wires, you goof. Get out of there. Come on. He doesn't know what to make of it either. Yeah, there's too many wires. Hey, you. Oh, he's going under. Somehow they can get under my bench. I have a whole pile of stuff stored underneath here. I didn't think there was any room, but they go under there. Okay, enough of the cats. Okay, enough saying okay. We're going to play this again. This time I'm going to leave it tipped up like this so we can get a more clear view of the smoke. And we'll see what happens. Coffee first. Okay, let's give it a try. So we're plugged in. We are switched on. The volume is up a little bit. Spot to watch is right here. Put some good light on it. I should have this guy ready. Yeah. The sounds you hear in the background are cats playing with plastic bags. Seems to be the order of the day for them. So this is set now 45, so it takes something around 40 degrees to make this go red. So my hand won't make any, there's nothing in here that's 40 degrees. There may be very shortly, so I would expect this guy to get up 35 to 40 in that range and nothing else. Okay, that's good. I was just quiet there for a moment. I'm going to be going through the dim bulbs, going through one bulb, so that's a heavy restriction. There we go. I'm just going to stand back. Wait, double check to make sure I put this in with the negative the correct way. Yes, I did. Okay, here we go. Da-da-da. So it's very low voltage, 36. It's going to take a long time. it certainly won't come on and operate, but this will give me a good chance to look for any heat. Nothing. Of course there's nothing. So what I'm going to do, since I have the voltage cranked low, I'm going to screw in the other light bulb here. That's going to jack up the voltage all the way to 60 volts. It's still way low. Okay, so we can see something appearing now. That's got to be this resistor here, and the temperature is it's going up to 30, which is about 40 already. Oh yeah, I can feel. Well, it's not very hot. Nothing else seems to be heating up. This thing is warming up? No, it's this. Yeah, I leave this on 24/7, so it's a little bit of heat built up in there. Okay, let's raise up the voltage from 60. We'll go way up to a little under 80. 80, up around 80 now. You see some red showing up. And I want to be sure that's the resistor. So oops, sorry about that. I'm going to use a blocking technique to be sure. Yeah. Yeah. So you can see red right in the middle there. She's warming up. And that temperature is, this device I'm using marks the highest temperature and lowest temperature, or detects it and writes it down here. So the highest temperature is 50. So this is getting up around 50. We only have 82 volts on this radio. Anything coming out of it yet? Little hum. Seems to be a volume effect though. I heard a little crackle. Let's take it up higher. Up around 100 it should start operating. So we're at 92. So it's 96. That should be enough. I do have the antenna connected, yes. This would be short. No, it's the other way around, isn't it? Oh, 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 oh. Oh yeah, this thing doesn't turn. So of course in Canada here we're totally concerned about the threat from the American president that he's going to put a tariff on Canadian products being imported into the United States. As crazy as it is, he is crazy enough to do it. It's stupid. But we have to get ready here in this country. And so how do you handle a crazy man? So Canada's doing what it can to try to stop the implementation. And if you're American, you should be thankful that Canada's trying to stop this implementation before it's a disaster of the highest order. Certainly for Canada, you know, our relationship with the United States is a 1 to 10 relationship, right? There's 1 Canadian for every 10 Americans. Actually, it's 9 now. 1 Canadian for every that's a 10 to 1 ratio. It's pretty hard for us, and to negotiate anything with somebody that big. It's crazy. I mean, it's like a wolf. No, I shouldn't say wolf. How about a fox? It's like a fox trying to negotiate with an elephant. You know, it's over. that's kind of what the fox knows. So, yeah, we're not a fox either. We're pretty straightforward. Canada's a very straightforward, very open, honest country that still believes in integrity, and I hope that doesn't go away because, yeah, anyway. Well, what are we going to do here? We can't tune the radio anywhere. Check and see if anything's getting hot.
Party is in. And you'll remember 2 days ago our Prime Minister called himself a feminist. Always a feminist. You'll always have an ally in me. And this will be yet another example
75 degrees on that resistor now.
or excluding a woman for not doing what he wants.
That's pretty high. That's 75 sitting out in the open here. So I put this back in the cabinet, seal this up. We got these two hot tubes on the top too. There's just so much heat right in this area. Holy smokes. That's the two tubes. The red stuff you see, of course, the tubes are very hot. How hot? How hot are they? So the machine may not be reading it correctly. 100 degrees C is what it's saying. You don't read the white numbers. I'm reading these little red ones here that you probably can't see. But otherwise, I'll go back over here again. Such a wide field of view from this camera. Okay, nothing is going wrong in terms of things burning up. So we can operate this radio like we are now, comfortably. Except for this hot resistor, but we're only at 96, so we're gonna see. A lot of these resistors are mounted. They're a special kind. They're mounted right on the chassis to draw the heat away from them rapidly. This one's been positioned next to the chassis to get some help, but really it's a cooker. It's cooking this. It's cooking everything in here. You always wonder why they wouldn't somehow figure out how to get that up on top, but I guess that's just too much expense. And this resistor is here because there's a 35 L6 instead of a 50 L6. 50 L6? 50 C6? 50 C5? I can't remember now. 50 L6 up there. I think the next thing to do is to get the capacitor going so we can tune the radio a bit. So I'm going to tip this down. I don't normally like to do this with operating radios, but the reason for that is the potential for dropping them is really high. Like if you're doing something where you think you might get a shock or something like that, maybe, and then you get a little nerve twitch, oh, throw the radio across the room. So we can't tune this radio because the capacitor just will not move. Let me see what I can do here with my hands. Oh, yeah, it moves. Not stuck. Why won't you go then? Now it goes. So not enough tension in the string. The string's kind of worn out, maybe. Hey, let's listen to this. Doesn't want to go. I was kind of waiting for some indication of who or what. Well, I think I see the problem already. I think it's pretty obvious what's happened here. Or what the problem is. Let's look closely at this spot right down here. This spot right here. So of course the string has to go around the tuning shaft. Usually it goes around 2 to 3 times. This one is not going around at all. It's just going by. So it's got almost no traction. Now what are those rubber pieces? Are they supposed to be doing something? They look like rubber pieces. Are they supposed to be like kind of grabbing the string? And they certainly aren't. So I haven't seen one like this. That's definitely rubber stuff. Let me poke at it here. I need something to poke with. Oh, don't poke those. So whatever they aren't doing their thing. You know, I wonder if this wasn't like a rubber spool, and so there was rubber. Like it's in two pieces now, but it was one piece, and I can't. And down here, there used to be a rubber piece, like the whole thing was a rubber spool. The rubber is gone. The rubber is gone. So fixing that, either we tense up the string a lot, which is tricky because the string tension is probably the result of a spring inside that big wheel. And how do you get to it? You'd have to take off this plate here, and the plate is screwed on. There was some things that you can spray like on the string to make the string stickier. I've never tried it. I don't know if I have any such stuff. I would be inclined not to try it. Or did somebody replace the string and then they didn't bother double wrapping it down here? It's not enough room to double wrap. And most of these shafts have a spoolie shape to them, so the string falls to the skinny part of the spool, similar to what these rubber shape is. Yeah, another way is to loosen everything up so much. This is probably what I should try. Get everything so loose and lubricated that there's no back pressure. All there is, back pressure on the string, is only coming from the actual capacitor here. Jim, don't forget this is on. There. So if we lubricate all this stuff, we might get away with it. Yeah, that's a good idea. I like that idea. That's a good idea. The idea is so good I'm going to stop and go drink coffee. Then we'll try it. Well, it's pretty late in the morning actually, and I got to go concentrate on getting more paint on my fingers. So I'm going to leave this right here, just as it is, and tomorrow we'll carry on with trying to improve its performance. And I'm like, no, wait a minute, I was going to lubricate this. Let me do that. Anyway. Sometimes this makes a big difference. Dusty mess there. Okay, get a little bit of a big brush for that. Okay. There. The only other lubrication is the shaft itself, but the shaft itself is not involved in the problem that we're working on. Okay, Mr. Radio, will you tune? Give it that. Well, we seem to have overcome that problem with just simple lubrication. The problem with the radio is, all these radios, when you get to the end of the run, what happens? If the string is so solidly installed, you're going to turn this harder and break the string eventually. So this has to slip somewhere. Something has to slip somewhere so you don't ruin the radio. And it's obvious where this one slips right in the knob, but most of them do slip down here. Well, that's good. Okay. Very good. Solved my problem and fixed something that was actually wrong with the radio too, and got it to work. Not bad. Now, I'm off to do that painting that I'm talking about. Let me just say one more thing about the painting. So our bathroom is wallpapered, and we're tired of the wallpaper. So we like painted surfaces better. So I decided, well, I've done this before. We just strip off the wallpaper and paint it. What could go wrong? Well, how about this? It's wallpaper on top of wallpaper on top of wallpaper, and each time they stripped away the surface of the wallpaper, left the backing page up, and stuck the new wallpaper up on top of basically the backing sheet from the old. There's at least 2 shots of wallpaper, and somehow I think there might even be 3 on there. But the worst part is they didn't put the wallpaper on a painted surface. They put it on bare drywall. So the first glued sheet, the sheet that glues onto the wall, you cannot identify that last sheet versus the first sheet of the wall itself. And so you try to remove the wallpaper with, water and whatever else I'm trying to do it. Occasionally I start digging right into the actual drywall and remove the top surface of the drywall, and you're just left with a mess. There's just nothing, there's no way to make it smooth and attractive again. That's what I'm up against. And I'm going to go continue working on it because I think I've got a solution for it. Thanks a lot for watching the video today, and tomorrow I'll try to put a full effort in here. See ya.